Okay, ladies and gentlemen, today we are going to dive into 5.2, and we are going to start off talking about roots, zeros, and x-intercepts. If you have a given polynomial, whatever polynomial it is, obviously this one looks really nasty, but your polynomial could be even something as simple as 2x squared minus 5x plus 1. Any polynomial and a real number b, x minus b is a linear factor of that polynomial. X has a power of 1, that's what makes it linear, and we've subtracted b, that's what makes it a factor. When x and b are together, that makes it a factor. B by itself is a 0, and b is a root or a solution. B is an x-intercept on the graph. Basically what you need to know is that all of these things tell you the same thing. X minus b tells you it's a factor. Then you can also talk about it being a 0, a root, or a solution, or an x-intercept. All of those things are the same thing. So if I tell you that something is a 0, you know that if you were to graph it, that's where that graph would cross the x-axis. It would be an x-intercept. So if I tell you if it's a root, a solution, a 0, or an x-intercept, I'm telling you all the same thing. So we'll find some of those today. So go ahead and pause this, write all that down. The other thing we need to talk about is the factor theorem. The factor theorem says if x minus b is a factor, or it is a factor, pardon me, if and only if b is a 0 of the polynomial. Meaning when I put b into the polynomial in place of x, it gives me 0 as my y value. Or, again, it's an x-intercept, a root, or a 0. Okay? So that only happens when you put b in as x and it gives you 0. So let's actually do one of these so we can figure out what this means. So write this down. It is an important theorem that you need to know and that we're going to use for the rest of the year. Okay, so here's my first example. For y equals x to the third plus 2x squared minus 8x, find the zeros and graph. Well, the first step of finding the zeros is that we need to factor this thing. So we look at that and go, okay, we are going to factor x cubed plus 2x squared minus 8x. So if I'm going to factor that, the first thing I'm going to look is see if there is a GCF. Is there a GCF? Yes, there is. All of the terms have at least one x, so I can factor an x out to the front. Then I have x squared plus 2x minus 8. So I can factor that with the AC method. So I find my a value. A is in front of x squared, so it is 1. C is the number without an x, so it is negative 8, and you multiply those together. You get negative 8. Now you make a list of your factors of negative 8. Well, 1 and 8 would give me 8, but I need negative 8, so make one of them negative. 2 and negative 4 would give me 8, but so would negative 1 and 8, and negative 2 and positive 4. Now I need to figure out which one of these adds to give me the 2. That gives me negative 7, that gives me negative 2, that gives me positive 7, that one gives me 2. So I rewrite this, x squared, split up the 2x to be negative 2x plus 4x minus 8, and now I group these to see what they have in common. So my GCF just rains down, bam, bam, bam. What do x squared minus 2x have in common? They both have an x, so I take it out. X squared divided by x just leaves me with an x. Negative 2x divided by x leaves me with a negative 2. So this set is done. Now I move over to this set. 4x minus 8, they have in common a 4, so I divide that out. 4x divided by 4 just leaves me with x. Negative 8 divided by 4 is negative 2. Now remember, these two things have to match. If they don't, then we factored incorrectly. Oh, I should probably set this equal to 0, since I'm finding the zeros. So my GCF comes down, then the two things that I factored out get written in the first set of parentheses, and my matching gets written in the second, and that is how we factor. we have factored these before, or we have factored before, and that's what our last quiz was over. So if you don't remember how to factor, make sure you either look over your notes or come in and find some help. So step 2, after I factor, I need to set each piece with an x equal to 0. So this is solving now, and we did this on the last quiz also. So I look, each of these pieces is separated by multiplication. So I have 3 pieces. So this first piece, does it have an x? Yes. So I set it equal to 0. The second piece, x plus 4, does it have an x? Yes. So we set it equal to 0. And the last piece, x minus 2, does it have an x? Yes. So we set it equal to 0. Now x equals 0 is already done. We don't need to move it. Okay? And if we were going to graph this, the ordered pair would be 0, because that's what x is. And then the y is what I set it equal to, 0. Here we subtract 4 to get x by itself, so what's x equal here? Negative 4. And its ordered pair would be negative 4, 0. This one, we add 2 to both sides, so x is 2, and my ordered pair is 2, 0. So I needed to find the zeros. These are my zeros, 0, negative 4, and 2, but I also need to graph. So down here on my graph, I can graph these ordered pairs. So my first 0 is at 0, my second 0 is at negative 4, and my third 0 is at 2. Okay, now that's not much of a graph. So what do you think we can do to find extra points? Well, we'll do step 3. That's not what color I want to use. We need to find some y values between our zeros. Okay, so here's my first 0. It's at negative 4, and my second 0 is not until 0. So what's about halfway between negative 4 and 0? Well, negative 2. So I'm going to take negative 2, and I'm going to plug it into this equation that I got when I factored. So instead of setting it equal to 0, I'm going to set it equal to y, so I can find the y value and have an ordered pair to graph. So my x value will be negative 2, my y value will be whatever I get when I plug this in. So it's x, so negative 2, times x plus 4, negative 2 plus 4, times x minus 2, so negative 2 minus 2. So that's negative 2 times 2 times negative 4. So my y value is positive 16. So I can go over to negative 2 and up to 16, and there's another ordered pair. That doesn't quite get me the whole graph though, so I need to find a value here between these zeros. So this is at 0, this is at 2, between them is x equals 1. So same thing, plug that in, 1 plus 4, and 1 minus 2. 1, okay. This is going to be negative 5. So here my ordered pair is at 1, negative 5. So I can graph that. And I can kind of see this shape. Like I know from this it's going to have to go up to get to this point and then back down to this 0. And then it's going to have to get to this point and get to that 0. But what about the ends over here and over here? Well, that takes us to step 4, which is our end behavior. If you look here at your equation, your leading coefficient is positive. So my leading coefficient is positive, and my degree, I have x to the first. Okay, we can go back up to the original. My degree is x to the third, so that is odd So I know that my end behavior, with a positive degree, my second word is going to be up. With a positive leading coefficient, my second word is going to be up. With an odd degree, that means my first word is going to be down. So I know at my last zero on the right, my graph is going to, after this, it's going to go up. And on my last zero on the left, after this, my graph is going to go down. So then all that leads us now with is step 5, where we graph and use our end behavior. Okay, I'm going to draw this with my erasable pens just so in case I mess up. So from this 0, I'm going to go up and grab this point, back down, through the next 0, down to this point, grab it, and then back up with an arrow for my end behavior, and that one's going to go down with an arrow for that end behavior. That's what my graph would look like. And if you wanted to check yourself, you could look at your graphing calculator and see if that looked close. You have a whole bunch of those on your assignment, so make sure that you understand what we did. So again, the first step, we factored. Take out a GCF if there is one. Go back and look at how to factor if you need to review that. That gets it set up into, these are called factors, when you have x and then x plus numbers and x minus numbers. Then set each one of those pieces equal to 0. That finds your zeros. So if we wanted to write that, we could write that our zeros are 0, -4, and 2. And we graph those on the x-axis because we talked about on our first page that zeros, solutions, factors, and x-intercepts are all the same thing. Then, to round out our graph and know how high and how low we need it to go, we pick values between our zeros. And figure out, you go halfway between, or pretty close to there. So if there's an odd number, you might not go halfway. You might pick one or the other. Plug that in. And then once you've got those extra points graphed, use your end behavior to figure out what the ends do. And that's how you graph a polynomial. Then our last things that we're going to do today is we are going to write some polynomials if I give you some zeros. So in this one, I need to write a polynomial with zeros at 0, -2, and 5. So step 1 is that I'm going to rewrite these zeros as linear factors. Okay, so we can look back here. If b is a 0, then x minus b is a factor. Okay, so right here I know that x equals 0, x equals -2, and x equals 5. Those are my zeros. So to rewrite those as factors, I need to get both of the things on the same side of the equal sign. So if I add 0 over, that doesn't really change it. So that's just going to be x. Now this one I would add 2 over and have x plus 2. And this one I would subtract 5 over and have x minus 5. So if it is 0, it will just be x. The other ones, you move them over and change their signs. Now, we will need to distribute and or FOIL as needed. So I'm going to FOIL first. You can do as you like. So if I FOIL, I will have x squared minus 5x plus 2x minus 10. And then if I combine my like terms, which are these two middle terms, I have x squared minus 3x minus 10. So that was my FOILing. Now I need to distribute. So I need to distribute that x to all of my terms. So my final answer is x to the third minus 3x squared minus 10x. This one gets a little bit more challenging. Alright, so same thing. We have a polynomial with these zeros, so we're going to rewrite them as linear factors. So x equals 2, so to move it over, we have x minus 2. X equals 2 again, so we have another x minus 2. And x equals negative 3, so we have an x plus 3. Same thing, but this time we don't have any distributing, so this will just be FOIL, and then we will have to FOIL again. So when I FOIL these first two, I've got x squared minus 2x plus 4 times x plus 3. Just bring that guy down. Okay. Actually, I want to skip a line. Okay, so now I have x squared, combine those, minus 4x plus 4 times x plus 3. Now you FOIL again. So you're going to take the, I'm going to do this in different colors so you can see. Take the x squared times that. So x squared times x is x to the third. Then you take the x squared times 3. X squared times 3 is 3x squared. So that took care of my first term. Now I take my second term times both of these. So negative 4x times x is negative 4x squared. Negative 4x times 3 is negative 12x. Then I take my last number times both of those. So 4 times x is 4x, 4 times 3 is 12. Now we combine our like terms. This is the only x to the third, and in standard form it should go first, so we write that one first. I have an x squared here and an x squared here, so 3x squareds minus 4x squareds gives me negative 1x squareds. And then I have negative 12x plus 4, so that's negative 8x, and then plus 12. Now I double check my work. Okay, that should be it. And then that one is finished. So make sure it's in standard form, and make sure that you did all your multiplication correctly, and good luck with your assignment.